Friends, in this video, I am going to share the wonderful material of 21st century, that is graphene, which has bring the revolution during last 20 years. Graphene is the hot center of research undoubtedly because it has number of applications. Before coming to the detail, in this video, I would like to give some introduction about graphene. Friends, myself, Dr. C.P. Bhasin, I am ex-senior professor of chemistry, हेमचंद्राचार्य नॉर्थ गुजरात यूनिवर्सिटी, पाटन, गुजरात. फ्रेंड्स, जैसा मैंने आपसे कहा, हमारी यूनिवर्सिटी हेमचंद्राचार्य जी जैसे गुजराती ग्रामर के एक बहुत ही ग्रेट स्कॉलर के साथ जुड़ी हुई है. एंड आई फील माई एक्सट्रीम प्लेजर to pay my tribute to Honorable Hemchandracharya ji. Now, I come to the point what I am going to talk about this lecture. I am talking about miraculous chemistry of sp2 hybrid carbon and boron. That will take a number of lectures. But as I did say in the beginning, this is a very introductory part which we know and we must know at very primitive step. I will come to the description or rather specification, some properties of carbon. We know carbon atomic number 6, atomic number 12.011, 0.025% on Earth's crust. Allotropes of carbon, we know diamond very well, graphite very well. But the another allotrope of carbon, that was Buckminster Fluorine, that was a football-shaped carbon molecule which totally outdated the theory that sp2 hybrid carbon can be in planetary shape. sp2 hybrid carbon can be spherical like a football, that was Buckminster Fluorine. But today my concentration is graphene. Before coming to graphene, I would like to compare some main properties. Diamond, we all know, very hard material, sp3 hybrid carbon. We know each carbon is attached to another for sp3 hybrid carbon, that infinite chain, three-dimensional rather structure I should say, that makes a carbon such a strong material. What is hybridization of graphite? We learn at very low standard, 8th, 9th, that is sp2. Graphene is nothing but the conversion of graphite into a thin sheet. Yes, what does it mean? When you take the graphite and you make the graphite so thin, you bring the graphite to a single atomic layer. That single atomic layer is known as this wonderful material graphene. So graphite is sp2 hybrid, graphene is sp2 hybrid. If we see the melting point, friends, you see the melting point of diamond 4027 degrees Celsius. Graphite, which is sp2 hybrid, melting point 3600. Graphene, sp2 hybrid, melting point 3652 to 3697. A little variation we can say. But the interesting point is that graphite is a multi-layer structure. We can see very well. We all have seen graphite in lead pencil. That is nothing but graphite. But graphene, which is single atomic layer, that is the miraculous material. That is the wonderful material. You will be surprised to know that the strength of graphene 1,000 times greater than the stainless steel. Such a strong material which is used in various fields, which I will talk later on. But we see the melting point very comparatively. No difference in melting point. We could expect the melting point of graphene much lower, but you are looking the diamond, again I will repeat, 4027 degrees Celsius, graphite 3600 and graphene 3652, 3697. But you see the electrical conductivity. Such a high electrical conductive graphene is. If you see the conductivity of graphite, we all know graphite is a conductor of electricity. But is diamond the conductor of electricity? No. What is the reason? Because all the 4 electrons of carbon, they are engaged in the bond formation. No free electron is there. But in graphite, 1 free electron is there because there is sp2 hybridization. If we will take the 3 orbitals, 1s2p, 1p orbital will remain unhybrid. That electron will be delocalized. Undoubtedly, graphite is the conductor of electricity. But if I see the same sp2 hybrid carbon of graphene, the conductivity of graphene, that is 4000 watt per mk. How much it is conductor of electricity? 1 unpaired electron, 1 free electron is in graphite, 1 is in graphene. But when graphite is converted into single layer graphene, that odd electron is demobilized like anything. Friends, generally I ask the question, if carbon is sp2 hybrid, should graphite is stable? Should graphene is stable? Because we are talking sp2 hybrid carbon. And simultaneously, I did say in very detail, elaborately, both graphite and graphene, undoubtedly they are conductor of electricity. Then what is the position? What is the structure of graphene? Undoubtedly, the structure of graphene is hexagonal. And the structure is like benzene. That electron which I am telling you that demobilize from one place to another place, both in graphite and graphene, but much higher mobility in graphene. So that electron makes the pi bond like benzene. Please be clear about this point. That makes the double bond, that makes the carbon tetravalent. Undoubtedly, that's why graphite and graphene are so stable. But when you pass the electricity, that electron which was involved in the pi bond formation, that is free to delocalize. Am I right? Okay, let us go ahead. The miraculous discovery of 21st century, single atomic layer known as graphene, was identified by John May in 1969. However, the awareness in graphene came through the publication of J.M. Nevoslov in 2004 in a very famous journal, that is Science, by their famous experiment, exfoliation of graphene from graphite using Scotch tape. Scotch tape, we all know, that is as we see, transparent tape, other type of tape. They put the tape on the carbon and they make the carbon in such a small particle by putting one layer to another layer that they were able to develop a single layer graphene, and they published their paper in Science 2004, and from that time the graphene was really wonderfully discovered. These are the young guys. See the photograph. K.S. Novoslov, Andrei Kazem. They were from Manchester Center for Mesoscience and Nanotechnology, University of Manchester. And what was their role? For groundbreaking experiments regarding the two-dimensional 2D material graphene. I did say undoubtedly graphite is 3D structure, but graphene is 2D structure. Friend, research on ultra-thin nanomaterials has grown exponentially in the field of material science, chemistry, and nanotechnology during last 2 decades especially. The capabilities for the preparation of ultra-thin 2D material with desired composition, size, thickness, crystal phase, particular importance for the further studies for their physical, chemical, electronic, and optical properties. Yes, very interesting pic. This is a very historical peak, I will say. The 2019 Nobel laureates in chemistry. Why it is historical? Every year Nobel Prize is given in the sixth field. There is a separate video, my separate video on this Nobel Prize. But out of three, one great person, John B. Goodenough from University of Texas, he received the Nobel Prize at the age of 97. At the age of 97, this great fellow received the Nobel Prize in chemistry. Another with two great scientists. Unfortunately, he left this world in June 2022. And for what was their contribution? All the three scientists. What was the contribution of Goodenough? That is true, he was 97 years old. But the contribution was the lithium-ion batteries which you are looking in each e-vehicle, e-scooter, EV cars. Everybody is looking like anything. When EV car will come and we will purchase. That is the miracle of chemistry. That's why I always say chemistry is the mother of all sciences beyond any doubt. And that lithium-ion battery, which was invented by Goodenough et al., they received the Nobel Prize. But simultaneously, I will talk about 2016 Nobel Prize for chemistry also. That was given to Jean Pierre, Stewart and Feringa for the design and synthesis of molecular machine. When we talk about the small, we should talk the small thing. A molecular machine or nanomachine refers to any discrete number of molecular components that produce quasi-mechanical movements in response to specific stimuli or input. Friends, this was very introductory part about graphene, revolutionary material. If you will listen my next video, you will find how much applicable this is in the every field. That's why I say it a wonderful and miraculous material. If you like my video, please share and subscribe it. Thank you very much.